Welcome to my YouTube channel. So I am discussing solid state physics concepts. Today I am going to discuss the difference between amorphous solids and crystalline solids. So I want to categorize what are the differences between amorphous and crystalline solids. So first one, amorphous solids, amorphous solids, crystalline crystalline solids. Amorphous solids, crystalline solids. So here the main difference between these, first one, non-periodic. Non-periodic. So the crystal structure will be non-periodic. It is not repeating. It is not repeating. And irregular arrangements. Non-periodic irregular arrangements. So simple. Non-periodic irregular arrangements. So in crystalline, if we go crystalline, this is non-periodic, this will be periodic and regular structure. Regular structure. So here in amorphous, non-periodic irregular arrangements. In crystalline, periodic and regular structure. So that means if we take a crystalline material, so this is a cube, it is repeating, so the structure will be repeating, so this is periodic nature. So in if you go amorphous solids, it's not repeating, so that is non-periodic irregular structure. Then second point, short range short range short range order. Short range order. Here if we take in crystalline, long range order. That means the periodic or regular arrangements will be in the long range. So if you go amorphous solids, this will be short range. So the repetition will be consist in short range only. Then what about bond lengths and bond strengths? Bond lengths and bond strengths. See, bond lengths and bond strengths. Bond lengths and bond strengths will not uniform. Not uniform. So here bond length and bond strength, bond length and bond strength not uniform. But if we go for crystalline structure, so bond length and bond strength will uniform. Will uniform. So here I am repeating. First one, in amorphous solids, non-periodic irregular arrangements. If we go for crystalline solids, that is periodic and regular structure. So the order will be short range order in the amorphous materials. Long range order will be in crystalline materials. The third point is bond length and bond. What about bond length and bond strength? That is not uniform here. Here bond length and bond structure it will be uniform. Then the fourth one, see, do not have do not have do not have sharp melting points. Do not have sharp melting points. Do not have sharp melting points. Sharp melting points. Do not have sharp melting points. That means, so 400 degrees Celsius to 450 degrees. That means here sharp melting points. So the melting point should be at particular point, the melting point will be sharply decrease or sharply increase. That means do not have sharp melting points. So at particular point, the melting temperature of melting is abruptly fall or abruptly increase. There is no that much. That is the difference is not there. That means do not have sharp melting points. But what about here? Fifth one, have sharp melting points. Have sharp melting points. Sharp melting points. Next, that is fifth point. Fifth point will be isotropic in nature. Iso isotropic. Isotropic in nature. Isotropic in nature. Isotropic means in all the directions. In all the direction, the physical properties are will be same. That means that is isotropic in nature. What about here? This is third, this is fourth, this point will be fifth. This is anisotropic. Anisotropic in nature. Anisotropic nature. That means here isotropic means in all the directions. If you take a crystal of cube, for example, if you go for this direction, whatever it is, in all the directions, the properties, if they are same, the properties, if they are same, then we can say that is isotropic nature. If they are changing in with particular direction, if the direction is changed, the property if it changes, that is anisotropic in nature. So amorphous solids will be in isotropic nature, crystalline solids will be in anisotropic nature. So last one here, sixth point, can't observe X-ray diffraction. X-ray diffraction. So we cannot observe using amorphous material. We cannot observe X-ray diffraction. But here we can observe X-ray diffraction. If X-ray diffraction. See, these are the main difference. I explained here amorphous solids and crystalline solids. Amorphous solids and crystalline solids. First one, non-periodic irregular arrangements, periodic regular structure, short range order, long range order, bond length and bond strengths not uniform. Here bond length and bond strength will be uniform. Do not have sharp melting points. They have sharp melting points. Here they not have sharp melting points. Here they have sharp melting points. So the amorphous solids will be in isotropic in nature. Crystalline solids will be in anisotropic nature. So amorphous solids can't observe X-ray diffraction, whereabout crystalline solids observe X-ray diffraction. These are the main differences between amorphous solids and crystalline solids. So I want to explain one more time. See, that means non-periodic, periodic, irregular, regular, short range, long range, bond length and strength, not uniform, bond length and strength, uniform. Do not have sharp melting point, have sharp melting points. It's isotropic in nature, anisotropic in nature. Can't observe X-ray diffraction, observe X-ray diffraction. Thank you.